Howdy guys. So in a previous video we were creating a barrel HDA and I skipped a little bit of the video while I did some math to create an expression for this bow amount parameter right here for our HDA. So in this video we're going to go over how I went about doing the math and writing that expression for any who are curious. So what we ended up having to do is we've tied our bow amount parameter to the soft transform here so that our bow could scale our barrel. But we noticed that as the bow amount scaled in, we got this overlap here in our mesh. So we needed to change this z-scale value of our bow amount so that when it was at a bow amount of 0, they didn't cross over, but when it was at a maximum bow amount, the middle of the planks or staves scaled appropriately. So to figure out what the relationship here looks like, we could try to find a linear relationship, like scaling the bow amount by 1.2 or 3 and type in random numbers to see what values we get, but from looking at it, I can kind of see that this isn't really a linear relationship. We're going to end up with some kind of nonlinear function curve. So what we're going to do is we're going to find 3 points, our minimum point, our middle point, and our maximum point for our bow amount, and associate it with the corresponding z-scale value. And then using those 3 points, we're going to create an equation that we can type into this scale factor so that it will scale appropriately. So let's dive right in and find our min amount. Think 0 and 1 look pretty good, so let's go ahead and write that down. And then for mid, it looks like we can go to 0.25 because that's halfway through there. And we'll just scale this until we get something that looks right. Let's do like that. That looks about good. Okay. So mid value is going to be 0.25 and 1.27. And then for our max value, I'm going to scale this all the way up to 0.5. And then I think what I had this on earlier was pretty good. Let's do about that, 1.55. So it's 0.5 and 1.55. So I can see with these points that this is almost linear, but it's not quite. It's a little off. So now that I've got our 3 points, we're going to go see about working out some of this math. All right, so first off, I apologize for my poor handwriting, but I will promise to do my best. So let's start out by recording our values. Let's see, our min was 0 and 1. Our mid was 0.25 and 1.27. And our max was 0.5 and 1.55. Let's go ahead and add a quick box around this. And so what we're going to do is we're going to plot these points on our curve. Let's draw a quick axis real quick so we can see. If this is 0, we'll start at 1. This is not going to be to scale, but I'm going to flush it out for emphasizing what we're going to be doing. And this will be 0.25, and this will be 0.5. So we're going to be starting our curve out here and ending somewhere up here. So what we're going to be doing, the curve's going to end up looking something like that. Basically what we're going to be doing is finding the equation for this curve. And that equation will look something like y equals ax squared plus bx plus c. All right. So now we have that. And that is where y will be equal to our z scale, and x will be equal to our bow amount parameter. So where do we start? Let's go ahead and get going. So what we're going to need to do is create an equation for each of these 3 points, and then use those 3 equations to find this equation. So let's go ahead and label this equations. All right, so the formula that we're going to end up following for our point equations is going to be d equals a little a plus b little b plus c little c. And that is where d is going to be equal to our y value, c is always going to be equal to 1, b is going to be equal to our x value, and a is going to be equal to our x value squared. So let's go ahead and try this out with our min equation. So for our min, that is our 0, 1, we're going to be using d equal to 1, because that's our y value. C is going to be equal to 1, because c is always 1. B is going to be equal to 0, because that's our x. And a will also be equal to 0, because 0 squared is still 0. So when we write our equation out, we get 1 equals 0 squared little a plus 0 times little b plus 1 times c. So these will both cancel out, and we'll end up with 1 equals c. All right, well, that wasn't too bad. Let's go ahead and look on the mid one. So here we'll have d is going to be equal to 1.27. C is once again going to be equal to 1. B will be equal to 0.25. And A will be equal to 0.25 squared, which is 0.0625. So when we write this out in equation form, it'll be 1.27 equals 0.0625 for big A, little a, plus 0.25b plus 1 times c, so just c. And that'll be our equation for our midpoint. Let's go ahead and continue that out. Let's go ahead and move over a little bit, and now we'll do our max equation. So for here, d is going to be equal to 1.55. C is going to be equal to 1. B will be equal to 0.5. And A will be equal to 0.5 squared, which is 0.25. So when we write this out, we'll end up with 1.55 equals 0.25a plus 0.5b plus c. All right. So now that we've got our three equations, we're going to have to find out how to use these three equations to create our main equation up here. To do that, we're going to do a simple 3x3 matrix. I say simple, this will be a little bit of work, but it's not too bad once you get a hang of the pattern. So again, we're going to be doing a 3x3 matrix. And we're going to be trying to fulfill y equals ax squared plus bx plus c. So we're going to be solving for our min, mid, and max equations to get a, b, and c values. So going through this method, our little a will be equal to the determinant of a over the delta or determinant of our three equations. And so the same will be true for b, will be for the determinant of b over delta, and c will be equal to the determinant of c over delta. So first off, we need to find delta, and then we need to find dA, dB, and dC. And then perform this simple operation, and then we'll plug in our numbers and we'll have our equation. All right, so first off, let's go ahead and calculate our delta. So the way we're going to do this is we're going to take our first point, our first set of points, our second set of points, and our third set. And then start off with a matrix. So we're going to use points A, which is going to be all of the little a's from these equations here. So it's going to be the a values from these equations and each one of these. So our first a value will be 0 from our min. Our second value will be 0.0625. Our third a value will be 0.25. Again, that's this 0, this 0.625, and this 0.25. Then we'll do the same for b, and again that will be 0 from here, 0.25, and I believe the last one was 0.5. We'll do the same thing for c, and that'll give us 1, 1, and 1, because our c was 1 in all three of our functions. So now that we have this matrix, we're going to calculate, or solve this matrix and calculate the determinant. So there's a couple ways to do this. I'm just going to go over one way. That's just the method that I like the best, and that is to multiply the matrix from left to right, and then subtract the matrix multiplied by from right to left. So our determinant will equal left to right minus right to left. And what I mean by that is we're going to take the left, starting in the left-hand corner, and multiply the values diagonally down and down. But we'll see we run out of room over here, So we can cheat a little bit and just copy these numbers over here and mirror them outside on the other end of our matrix. So we'll do 0, 0.0625, and 0.25, and 0, and 0.25, and 0.5. And now we'll copy from here to here. So this is going from diagonally left to right. We're going to be going 0 times 0.25 times 1. And then we're going to grab this diagonal right here. And that's going to be 0 times 1 times 0.25. And then we're going to grab this value right here. And that's going to be 1 times 0.0625 times 0.5. So when we add those together, that's just 0. The second one is also 0. And that third one will come out to 0.03125. So 3125. That will be our left-right value. So we're going to do this the same for going from right to left. So we'll start over here and the far right and go down. And that will give us 0 times 0.0625 times 1 plus this one right here, which is 0 times 1 times 0.5. And then our last column, which is right here. And that will be 1 times 0.25 times 0.25. And again, this will be 0. This will go to 0. And we'll be left with 0.0625. So now we're just going to subtract this value from this value. So in doing so, our delta will be 0.03125 minus 0.0625, or negative 0.03125. All right, so now we're going to do something similar to find the determinants for A, B, and C. All right, so now what we're going to do is solve for dA. And what we're going to do for that one is let's make our matrix again. That'll be P1, P2, and P3. And now, because we're solving for the determinant of A, we're actually going to, instead of our A column here, we're actually going to put our D values here. And again, those are the D values from each of our 3 points, so 1, 1.27, and 1.55. And then we'll put our B values down. And again, that'll be 0, 0.25, and 0.5. And then our C values are once again going to be 1, 1, and 1. And now we'll just solve this matrix just like we did the previous problem. So once again, we'll be going from A is going to be equal to left to right minus right to left. So let's go ahead and mirror these on the other side. And we'll go diagonally down and do this one more time. So for our left to right, we're going to be getting this guy, and this guy. And that'll come out to 1 times 0.25 times 1 plus 0 times 1 times 1.55 plus 1 times 1.27 times 0.5. And then that will come out to about 0.885. And then going from right to left, we'll go down diagonally the opposite way again. And then that will give us 0 times 1.27 times 1 plus 1 times 1 times 0.5 plus 1 times 0.25 times 1.55. And then when we calculate this out, that'll go to 0, that'll go to 0.5, and that'll go to 3.3875, which will give us 0.8875. So then we'll just subtract this value from this value. Again, left to right minus right to left. And that will be dA equals 0.885 minus 0.8875, or negative 0.002. All right, so we'll go ahead and do the same thing for DB. So we're going to do the same thing for DB, and for DB, we're going to start off with our 0.1, 0.2, 0.3 again. And then this time we'll use our A, and now we'll be using D in place of our B column. Let's go ahead and write in our A's, and those were 0 and 0.0625 and 0.25. Our D values are again 1, 1.27, and 1.55. And then our C values are again 1 in each column. So again, our DB is going to be equal to left to right minus right to left. So we'll go ahead and mirror that over here and solve our matrix. 0.625, 0.25, 1, 1.27, 1.55. And we're going to go down here, here, and here. and this will be for left to right. And that'll give us 0 plus 0.25 plus, that'll end up being calculator 0.96875, or a total of 0.346875. And then we'll do the same going back the other way. There's 3. And that'll be right to left. And that'll give us just 0.0625 plus 0 plus 1.27 times 0.25, which is 0.3175, for a total of 0.38. So we'll just subtract this value from this value, and that will leave our dB equal to negative 0.33125. All right. So now that we've done dA and dB, I'm going to skip ahead a little bit and solve for DC. All right, and now we've solved for DC. I got negative 0.03125. And now that we've got that, let's go ahead and solve for the actual values of A, B, and C. So, once again, it's going to be A is equal to dA over R delta, which was, our value for A is negative 0.0025. And that'll be divided by R delta over here, which was negative 0.03125. And that'll give us 0.08. And then we'll do the same for B, which was negative 0.033125 divided by R delta again, which was negative 0.03125. And that would be equal to 1.06. And then our value for C will be, C I think is actually the same as our delta determinant. So it's negative 0.03125 over negative 0.03125, or 1. So now that we have the 3 values for A, B, and C, we simply need to plug those values into our function up here. So we'll have y is equal to 0.08 x squared plus b, so 1.06 x plus 1. Again, that's where y is our z-scale, which means we'll be putting this expression into our z-scale parameter, and x will be a reference to our bow amount parameter from our HDA. So now that we've got this made, let's jump back into Houdini and plug this expression in. Alright guys, now that we're back in Houdini, let's go ahead and plug our expression in. So, if we remember, our equation that we just got was y equals 0.08 x squared plus 1.06 times x plus 1. So now that we have our equation, we're going to go into our z-scale and copy our bow amount parameter. And let's go ahead and set this 0.08 times paste the relative reference of our bow amount. And the way we square this value is we're going to need to go before it and type pow, parentheses, and then after it, comma, 2, and close parentheses. And what that is doing is the power function raising this reference amount by the power of 2. And then we'll add 1.06 times, and again, our relative reference for our bow amount. And then we'll add 1 and hit enter. And now we'll see that our barrel bow amount will scale appropriately and transition between our min, mid, and max values. So I hope that was helpful. I know I'm not the greatest math teacher, but I find it really helpful sometimes when I'm trying to create a non-linear relationship between two parameters.